So we're going to be solving an interesting problem of fraud detection, but in the insurance space. Now, this particular data set, so it has to do with vehicle insurance fraud detection, and so for this data set, we'll be looking at so some people are conspiring to make false or exaggerated claims involving property damage or personal injuries following an accident. Some common examples of this include staged accidents where fraudsters deliberately arrange for accidents to occur. The use of demo passengers, people who were not in the scene, come acting like they were there and they had an injury, and they are having a couple of this okay, everybody placing a claim and trying to defraud the insurance company. Good. So we gracefully, the insurance company was able to provide us this particular vehicle insurance fraud data set, showing a list of different behaviors from different users. For instance, on December 5th of December, Wednesday, so the person who filed this particular claim, the person of this particular behavior was using an Honda car, accident area urban, day of the week claimed Tuesday. So each of these things are claims. Month claimed January, week of the month when the claim came in. This is the first week. A female that claimed, and the marital status, she's single, she's 21 years old, policy holder, policy type, sports liability, and if we keep looking at this, vehicle price higher than $69,000. And good. So we have all of these column names down to if that particular claim was a fraudulent claim or not. So meaning the insurance company went ahead to do some background checks on each of those claims and figured, oh, these claims were fraudulent, these were not fraudulent. So 0 means the claim is not fraudulent, and 1 means the claim is actually a fraudulent claim. So from this past behavior of several claims, of several customers who have filed these claims, we are going to use it to predict the likelihood of another claim that is being filed, if it's a fraudulent claim or not. Beautiful. So we're going to train an AI system to learn the patterns of fraudulent claim and non-fraudulent claim, and from understanding these patterns, it can decide if a new claim that has been imputed into the system or a new claim that the customer has actually filed, if it should be honored. Good. And give reasons why. Beautiful. So before we go ahead to build our model, it's a beautiful thing we get to check out data analytics around our data sets and see some interesting stuff we can put together. So let's give this some seconds. Visualization is done running, and we can already see several plots, heat map, time series. So come play with each of these items, come play with each of these charts, and digest some more interesting stuff. But firstly, I like to first play with the carver plot. So what can we see from here? A month, week of the month. Okay, so these are various claims, and so December had the most claims. Good. We can look at each as to, so let's first try with gender. Okay, so we can look at, so from this we have more aged males who filed, yes, who filed claims. Good. Let's also look at age. I'd like to see all vehicle category, and we can see more younger people drive sports cars. Good. We can also check out number of cars, and we can see more than 8 cars. Younger people have more cars, more than 8 cars. Interesting. Okay. We can also marital status, no. Age of vehicle, and we can see more than 7 years of vehicle, older people, which is quite normal. Let's now look at fraud and age. So more elderly people filed claims. More elderly people have less fraudulent claim. Younger people have more fraudulent claim. Good. There's just something about the younger generation. Okay. We're actually great, guys. Let's look at fraud again. As to driver rating. So driver's rating. Okay. So we don't really have any more significant importance, but from this we can see that even the guys that have the highest driver's rating are the ones who have more of the claims. So good. Let's go straight down building our model. You can continue to play with each of those auto visualization charts and come up with some interesting insights from your data set. Very important. From charts like that, you can already find out if your data set is balanced or it is not balanced, and this actually means a whole lot. Good. So vehicle insurance, we're going to navigate down to projects. I'll call it vehicle insurance fraud detection, and then we can paste similar stuff here and we'll create a project. Beautiful. So now we have on Autogon AI, there are several products that can be used to build powerful AI models. There's the Auto ML that you could use in less than 3 steps. You're done building a very powerful model, and you can use the studio environment. It's a no-code AI IDE where you have full custom control to whatever model you're trying to get out of the ground. So I'll just go ahead and launch Autogon Studio Wizard. We're going to use for this particular video. Selected 16 data sets, and we'll select the vehicle insurance data set. We'll give this some seconds to load up. Okay, so even straight up from loading this data set, we can already see week of the month, week of month claim of high importance, policy number really matters, age, but policy number significance, it's very, very high. Oh, the year as well actually matters. Beautiful. So just click on the next button. Now what's the target variable we are trying to predict for is actually a categorical variable, that's a fraudulent or non-fraudulent activity. 0 means non-fraudulent, 1 means a fraudulent claim. So good. So so it's a classification problem we're going to be selecting because we are trying to predict a binary classification categorical variable. So we're going to go ahead and select classification, and training target we're going to go and select the fraud found P, and we'll call this vehicle underscore fraud detection. And please, just so you know that you can use whatever name, it actually works. So give this some seconds to load up, and in the GIF we're going to see the accuracy that we are getting. Model training is done, and we can see we have an accuracy of 0.94, which is actually a 94% accuracy. Beautiful. One way to calculate this accuracy also manually is to sum this cell and this cell divided by the sum total of every single thing. But yes, we have an accuracy of a 0.94, which is almost 0.95. So just a 0.05 model is underperformance. So the accuracy of a 94-95% is actually a very good accuracy. Good. So I'm going to show you how we can already begin to inference our model. But before we do that, let's click on this feature of importance. So our model says from the target variable that we're trying to predict, the policy number actually matters a great deal. So different users have different behaviors to different policies. The age matters, the rep number, the driver's rating, and all of these other guys, but the policy number actually matters. Great. So we're going to select prediction now, and to actually carry out a prediction, we can actually do this in a very simple fashion. Model. Let's open the data set real quick again. Now if you observe, all of these columns are actually the independent variable aside the fraud found underscore P column. So this is the dependent variable, and every other column is the independent variable. So if we are trying to predict a new transaction to check if it's fraudulent or non-fraudulent, we're going to supply all the independent variable of that new transaction to determine if it's a 0 or a 1. A 0 meaning it's not a fraudulent transaction, and a 1 meaning it's actually a fraudulent transaction. So now to test our model, I'll already open up the data set we used to train it, and I'll just take some sample observations so we can see. So yes, these are the column headers, and so you can see this is the first observation all to this corner, and so we can see the 0 meaning this is not a fraudulent transaction. So I'm going to take all of this down to this place, and I'll use it to inference our model. And to do this on Autogon AI, you can't impute this data set like this directly. You have to create a data set out of this string item and use that string, that data set, to inference your model. So to do this, I'll just hop down to Autogon Quick Predict, and select vehicle insurance fraud detection. Select, and if I create a data, I can create a data set right away from here. Select one dimension and I generate. So good. So copy this. I can now take this to our model and supply this as a test data set. And if I click on predict, beautiful, we see that we just got a prediction. And what's the prediction label? 0, with a prediction accuracy of a 0.9942, in which what is the prediction here? 0. So our model actually predicted this particular transaction correctly, saying that this is not a fraudulent transaction. Let's pick another observation. So this is an observation again. We're going to pick from this to this end, ignoring this last comma and the 0. So we're trying to predict this dependent variable, and I'll take you down again to quick predict, and then we create another data set off of this. Select one dimension and we generate a data set URL, just in case you want to visualize this, what we just generated. So this is what we are passing to our model. Good, and you can do this seamlessly via the API. So I'll come in here and supply a new test data set, and if I inference this, so let's see what our model says about this. And we can see our model predicts that this is not a fraudulent transaction, again with an accuracy of 0.99, and we can also see this is actually not a fraudulent transaction. So let's look for a sample fraudulent transaction. Yes, so this is a fraudulent transaction. So I'll pick this from here, and I'll go ahead, we'll create a data set off from this, and we'll select one dimension, and we'll generate a data set. Beautiful. Copy our data set, and we'll go straight to our test data, and we'll supply this as an input to our model, and let's see if our model is going to get this prediction accuracy. And beautiful, our model predicts a 1, and meaning it's actually a fraudulent transaction with a prediction accuracy of a 0.742. Beautiful. So we have built the model, and we've even tested the model from our existing data set we're using training the model, and we can also test out our model from a new observation. So meaning a new claim is being filed, we can call our model via an API, or we can take that new claim. If you don't have a back office, come impute it on Autogon and inference your model to ascertain if that new claim is actually a fraudulent claim or it's not a fraudulent claim. Beautiful. So to inference our model via API, it's important to create a pipeline, and so I'll just show you how to create a pipeline. Then we are going to go inference our model via an API. Good. So to create our model, to create our pipeline, we just simply enter vehicle underscore fraud underscore pipeline. You can enter any name. I just like to keep different tags together so I don't forget. And good, we have a pipeline already created. So let's test out our pipeline. We'll test out our pipeline first on Autogon Quick Predict, then also we would test out our pipeline via an API call. So now if you look at this is the project we built, and this is the model we had built out of that project. Okay, let's just do a quick refresh. Select the project, select the model, and we have a data link already. So I've just imputed the data link, and if I go select the pipeline, vehicle fraud pipeline, and I predict, and beautiful, we can see the model was inferenced, and we can see what we just got. The claim is actually a fraudulent claim. So the same thing, we can create another data set. So we just copy this. So we're trying to predict if this is a 0, and we'll go ahead and create the data set of from what we've copied. I'll copy our data set. We come inference our model. Oh, okay, we're inferencing our model. We change the link from here, our pipeline, select vehicle fraud, and beautiful, we got a 0, and actually it is 0. Beautiful stuff. So I'll now show you how to inference, do same thing from your, that's via API. So all we need to do is I'll copy the same data set, and I'll come to API. I already have a collection here open, and I'll update the data set here, and I'll come copy the pipeline. So to copy the pipeline, you have to go open the project. So vehicle insurance fraud detection. If I click on view details, I can see the pipeline, and I copy the pipeline, and I come back to Postman, and I update the flow ID of the pipeline, and I hit the send, and beautiful. So we can see we already have our prediction data set, and if I open prediction data set and I open this, I get 0. So meaning the transaction was just inferenced is not a fraudulent transaction. I can always go back into Studio Wizard and select models, and I will see the last model I built, which is actually 94.5, about 95% accuracy. Beautiful. And if I select the model, I still get to see my confusion matrix and feature of importance. Good. So yes, so we are going to wrap up here. Thanks, guys.